So I can't do the 4 through the 10. So the 10 has to stand. How many times does 4 go into 5? Once. So 1 comes out, 1 stays in. How many times does 4 go into 8? 2. 2 come out, the leftover. How many times does 4 go into 10? 2. So 2 come out, and how many are left over? Okay. Remember, as you go through these things, it's just the reason that I'm doing it that way is because it's cleaner and quicker than rewriting everything as fractional exponents and actually simplifying them, because that's just a big pain in the butt. You kind of look like a weeble wobble. I think you should tell people about that.
Were you the high school bully?
No, I was not. All right, I'm sorry. All right, let me rephrase this. His nickname was Weeble Wobble, and he was okay with that.
Are you sure you was okay? Are you sure?
You guys are all worried about poor, what's his name? No, his name. I remember his name. I'm not going to tell you his name. You guys can look him up. I'm going to try and find him. So, Mr. Weeble Wobble. So, okay. No. His license plate say "We Wob."
That's only 6 letters.
Weeble Wobble. Because you can have 7 letters on a license plate. All right, so anyway, back to math, because that's kind of what we're trying to do. This is another one of those examples since they already have all the same nth root. Rewrite them as one giant square root. So when I do that, I'm going to get 2x, y to the 4th, z to the 5th. Now, the nth root that you don't see is always a 2. So if it's not there, it's implied that it's a, bless you, it's a 2 here. Can I take the square root of 2? No. So I know it's going to be a 2x, because I can't simplify that. But then how many times does 2 go into 4? 2. 2 come out, there's no left over. How many times does 2 go into 5? 2. 2 come out, and there's 1 left over. What should you try before you go home?
Well, I do. But then I have the same situation. I mean, what would I do?
So hard to get help. If we were only ever, available to help you.
Like 23 minutes.
Good times had by all. Hey, I'm going to collect this assignment tomorrow. I'll be okay. Well, thanks for asking. Now, if you like, I can designate a cookie taker for you, and then that cookie taker person can leave it for you on Monday. Ladies and gentlemen, is anybody willing to be a cookie picker upper and not cookie eater tomorrow? I don't trust you as far as I can throw you. I would trust Barnes. I would trust. She looks like she could be somewhat trustworthy.
I'm not trustworthy.
So I would suggest that maybe looking around the room, write up a small contract. We will notarize it because I'm a public notary. Yeah, why not? I got a stamp. I got a stamp. I'll use my 3-hole punch. We'll make it legal. So,
We'll tie it together with string.
And put a bow on it.
We'll seal it with blood.
So I would suggest that we write up a little contract saying blah blah blah, will pick up Emily's cookie and I will not eat it. So help me my stomach. You will pay a fee of, how much are cookies on Thursdays from Target? They're $1. No, the Target. All right. Listen. So yeah, they're $1. They're the cookies they sell at the coffee place in the high school, their Target program, the coffee program they have here, not like Target. Okay. They're not wearing red shirts and caps, okay? So they're 50-cent cookies. All right, so then if they eat your cookie tomorrow, then it costs them $1 next week, so you get a bigger cookie next week. So I would write up a little contract, I'll notarize it, and we'll hang it on the wall, and then we'll shame that person for like 2 weeks straight. Why not? But it's more fun to shame people. Shame. Anybody else not going to be here tomorrow that needs to get a cookie picked up? In my brain, it sounded good. But then again, a lot of things in my brain sound good. You're just going like, what the hell is going on in this class today? I don't know. Hey, let's get working. I don't know. We're all on the right track. Here's the first one. Now, whenever I'm doing these problems, the first thing I'm going to take care of is numbers. In this case, I just have a 2. I have m to the 7/4, m to the 5/4, which means same base, different exponents. I just add them. 7/4, 5/4 is 12/4, otherwise known as 3. So I have m cubed. Next thing I have is an n to the 4/3, and then the n to the 3/2 is down the denominator. 3/2 is greater than 4/3. So when I move that around, I believe you get a 6th in the denominator?
Yeah.
Okay. So what it means now when you have 2m cubed over n to the 1/6, it says no fractional exponents in the denominator. So in order to get rid of the fractional exponent in the denominator, I have to create a whole. In other words, what we're doing is rationalize. How many more 6ths do I need to make a whole? 5 of them. So I multiply the top and bottom by a factor of 1. That factor of 1 happens to be n to the 5/6, which gives me a whole in the bottom. And in the top, I get 2m cubed n to the 5/6. And you're done. Okay. Now, one of the things that actually 12th hour picked up on, what the 12th hour picked up on this was that more often than not, if you have a fractional exponent in the numerator and the same base as a whole in the denominator, you can't do anything else because you get to that infinite loop of moving it back and forth, back and forth, back and forth. Whereas if you have a fraction in the denominator and a whole in the numerator, that's usually when you can move stuff around. Okay, so if it's just fraction up top, whole in the bottom, you might not be able to do something. Does that make sense? Did that help just to get the first one rolling?